Welcome to homework.
Now here in this problem they are saying that air at pressure 3.5 megapascal, so P1 is 3.5 megapascal and T1 is 500 degrees Celsius. It is expanded in adiabatic gas turbine to the final pressure as P2 is given as 0.2 megapascal, and our aim is to calculate the maximum work that can be obtained from the turbine in kilojoule over kg. Now you can see this thing, the same the process in the TS diagram also. That is, this is state 1, state 2, and the pressure is 3.5 megapascal at state 1, and at state 2 it becomes 0.2 megapascal. Now we will be requiring some input data, that is the value of Cp of air corresponding to an average temperature of 550 Kelvin will be 1.040 kilojoule over kg Kelvin. We are taking the average temperature of the process to be approximately 550, and according to this pressure temperature we are getting this value, and the value of K, that is the specific heat ratio, it will be 0.381, and we have obtained this value from the table A to B. Now the work output for this turbine will be equals to H1 minus H2, and we can write this equation by using the energy balance equation, and from that equation we can write this the work output as H1 minus H2. So H1 we know it is Cp T1 minus T2. So we have the value of T1 but we don't have the value of T2. For that we'll be using then equation of isentropic process, that is T2 is equals to T1 times P2 divided by P1 to the power K minus 1 divided by K. So T1 we are given as 500 degrees Celsius. If you convert this thing into Kelvin, we have to add 273 to it, so it becomes in Kelvin, times P2 divided by P1. So P2 we have 0.2 megapascal divided by P1 we have 3.5 megapascal to the power K is K minus 1 will become 0.381 divided by K is 1.381. So after solving this we'll get the value of T2 as 351 Kelvin. So we can plug all this value in this equation. So Cp we have it's 1.040 kilojoule over kg Kelvin times T1 minus T2. So T2 we have 500 degrees Celsius, but we have to convert this thing into Kelvin, so we'll get 773 Kelvin minus T2 we have 351 Kelvin. So after solving this we'll get the value of work output as nearly 439 kilojoule over kg. Now in the starting of the question we have assumed that the average temperature of the process to be as it's 550 Kelvin, and if we see actual what is the average temperature, it will be 1 divided by 2 T1 plus T2, and T1 is this much and T2 is this much. So after solving this we'll get the value of average temperature as 562, which is nearly to the assumed value. So we can assume that this data that we have taken is almost true. So this is the final answer for the given problem. I hope you find it the problem easy. Thank you so much.